Okay, and our next speaker in the advanced advertising session is Matt Poole.
A little bit of overlap. Okay. That's
Okay.
fine, it's good.
So Matt is the head of online architecture for ITV, and his talk is deploying dynamic ad insertion with Dash, a broadcaster's architecture.
Can you hear me okay? Yeah? Okay, so when I first said that I was coming to Denver, I got really, really excited, so I went straight over to the Visit Denver tourist site. And imagine my surprise when I saw on the Mile High Video website the same, no, I stole it from the website. So that's the only joke. Laugh it up, guys, because that's the only joke. In case you don't know who ITV are, we're the biggest commercial broadcaster in the UK, got 6 broadcast channels, but we're also a global content producer as well, including ITV Studios America over here, and we have broadcast channels in selected areas of Middle East, Asia, and Africa. And direct-to-consumer. Most broadcasters have got their own direct-to-consumer proposition as well, which I'm going to use as a vehicle to talk about how we've gone about deploying things so far. So when I was asked to talk, I said, guys, we haven't actually finished deploying it yet. And they said, well, that's fine, don't worry about it. So I'm going to take you through the story so far, and we're going to talk about the project, the background to the project that we're going to deliver it, and talk about broadcast architecture all the way through from scheduling systems all the way down through to the media player client. And hopefully we'll come up and touch upon some of the topics that are useful in this area. So about in November 2016, the background, we started looking at live OTT. By the way, I should say this is only talking about linear, not VOD. And the reason for that is that we're pretty adept at doing client-side VOD insertion, but we think that it's necessary for live OTT to do server-side, so that's an important distinction for the talk. But we're looking at strategic themes. We wanted to improve our content, which basically meant doing better with the rights we have, which just meant doing more DRM. We wanted to improve the distribution of our live OTT, which meant supporting more DRMs, doing more streaming formats, excess services, and so on. We wanted to increase our revenue capacity, which meant that after we've distributed everywhere, we want to make sure that all of the adverts, as many of the advert breaks as possible, were replaceable. And we wanted to make sure our architecture was as efficient as possible so we could roll out viewer benefit as fast as possible. So with that strategy in mind, we looked like looking at a vehicle we could use to start tackling that. And we chose the web, and the reason basically is because we were still on Flash for live. We'd done HTML5 for VOD using Dash.js, but we needed to replace Flash. We'd had a go at server-side already, HLS just on the iOS platform, but there was lots of proof of concept software with no product team looking after the software. So, and certain areas it weren't aligned with strategic tech that we're doing, particularly in transcode. And our Flash player currently, our first attempt at ad replacement was actually in the client side for linear, using RTMP with Q points in Flash. And obviously that's more of an art than the science, let's put it that. So we wanted to replace that. So we got off thinking about that, and we're busily thinking about that. Meanwhile, the market for targeted advertising was really, really getting hot, and we started looking at broadcast linear ad replacement, so replacing broadcast adverts with IP adverts, basically. So these two things were going on at the same time. So we thought, well, actually, let's start thinking about these two things together. So what began as a let's replace web ad replacement with server-side ad replacement with Dash became a project aligning and driving core platform enhancements on our broadcast chain to allow IP ad replacement on broadcasts. So one of the most important things that we wanted to do was standardize the signaling across OTT and broadcast. And we've been working in DVB recently. If you're familiar with DVB-TA, it's no accident that the DVB-TA is attempting to tackle SCTI, probably SCTI, I don't want to preempt it, definitely SCTI, across broadcast, vertical and horizontal broadcast use cases, but OTT as well. And by aligning ourselves with that, we just basically got better project momentum. It's OTT enhancements drove broadcast enhancements drove OTT in this particular space. And to a lesser degree, it's helping us move towards IPTV because we've got common concepts, but that's kind of a lesser point for us because we are a broadcast multiplex operator, so we still think broadcast is very, very important. For the project itself, it was moving out of band signaling is very important because we're aligning with broadcast. In-band signaling was necessary, so we wanted to move out of the band signaling. In our broadcast playout, we use Miranda cards specifically just for the OTT playout. So we wanted to get rid of that. If we're going to align, then we needed to remove these cards and become more scalable. There's a little bit more about that later, which added up to much greater operational simplicity. So we already were doing some, as I said, we're doing some ad replacement. In the scheduling system, we already had the ability to look for the schedule and where we had the rights, because you don't always have the rights to do ad replacement. When you're acquiring content, you don't always get the rights to do ad replacement. But we were already doing that bit. But the new bit, and I think it was mentioned earlier, we started signaling common spot and break IDs and minting them in the scheduling system so that they could go onto the ad decision server. And these spot and break IDs are passed on via broadcast exchange format to the playout system, and in-band in the SCTI 104s, they're inserted in the ICEs, which is upstream of the Miranda card, which means all of the broadcast platforms on OTT will inherit the same SCTI 104 events when you get down to the encoding platforms, and then when you get to the SCTI 104s being converted in OTT platforms, you get your SCTI 35s. If you're interested, our SCTI 35 and 104 specification is on GitHub, and if you want to check out the slides afterwards, you can see how we've approached it. In the project, we then had to take a look at our OTT encoding platform. You can see here how we've got for data centers to contribution sites and to distribution sites. The SCTI 35s are carried in the contribution TS file in a 50 megabit stream to the distribution site, where they are then output as an AVR set as fragmented MP4s. So looking at the OTT platform in a little bit more detail, this is where we started getting some challenges. It's stuff that was new to us. We hadn't actually encountered challenges yet. In the distribution encoder, I should say actually, so our packager requires smooth as an input. Fragmented MP4s, but it's essentially a smooth wrap around the fragmented MP4s. Our encoder did support carrying splice events in the sparse track, but it didn't support carrying payloads, so we couldn't carry the break IDs and spot IDs were not being transmitted from the encoder, so we had to do a bit of work there. So it's an elemental encoder, but for us, elemental encoders are now carrying payloads as well as the splice inserts in the output. We deliver that over a 10 gigabit AWS direct connect up into AWS, where we've got our packaging DRM system. So the way we represent the SCTI is in the ESAM specifications. It's carried as a binary blob as XML, as you saw earlier. Our packaging needed to be able to parse that, and so that's the next piece of work we had to do. So we're parsing out the SCTI as XML to start looking at the packaging for ad replacement. Now you might ask, what about solving the problem with smooth? Do you really want doing smooth? Going forward, probably not. So we're involved in a project by Unified Streaming where we're trying to make Dash as a contribution format to packages for carrying in-band metadata. Trying to use as much as possible what's already in the Dash spec. That wasn't the way it started, but that's the way we're steering it. So hopefully Dash will be able to be a contribution format or even better CMAF, as a contribution format for packaging ad replacement. We've got two entirely isolated active live chains doing packaging for ad replacement. A little bit about some experiments we're doing with how we scale out. So we started with, we've got multiple origins in each chain. And we started with experimenting with EFS as a storage medium, because that gave us seamless failover, because the archives for each packager were distributed across them. What we found, though, is that AWS EFS is not really right now optimized for latency-sensitive applications. So, and while AWS guys have been working quite hard and they've made a lot of releases improving things, moving forward into true low latency Dash or HLS is probably not the right thing for us right now. So we moved on inside having a look at NFS clustering. So we've now got a highly available NFS cluster, but it's not active-active. But the performance is really, really good. So I think that's, for us, the right approach for low latency when we get there. But we've had to solve the not being active-active, not delivering to get to a seamless failover with pretty low-level file synchronization. But that's not my, we're not going to talk about that right here. So back up to where the origin is now outputting a condition stream for ad replacement. So let's take a bit of a closer look. We heard a little bit about this. So we've got an inputting stream coming in where we've got a regular cadence, fragments are of equal length, and there are add avails. We've heard that SCTI is conditioning, so the encoder is putting in IDRs in all the right places, but the outputted segments need to be aligned around period boundaries. So using the permitted sort of plus or minus of a half of the segment duration, we did some work to make sure that we could segment the dash output to be able to land on a segment boundary, on period boundaries, either side of the period boundary. You can see it there being truncated. We've heard a lot about the date range. So in this new product, we're starting with the date range. In our old live stream, we're on what we heard earlier. So the date range in HLS specifies there must be a matching splice event at the end as in the beginning. For us, we only, as a broadcaster, rely upon duration, which is what SCTI 35 spec says is the recommended way of doing things. So we don't actually transmit a close or back to network signal, we just rely upon the duration. So in the case of HLS, with the date range, it meant we had to do a bit more work in the packager, whereas Dash, inherently talking about presentation times and durations just works. So in this particular case, Dash is slightly better for us in packaging than HLS. I thought just before we go into the next slide, just a reminder that we're talking about spots and breaks. So because we're aligned with broadcast, and broadcast, actually what you're trying to do is replacement of broadcast ads with IP ads. You're actually trying to replace just a spot because you're selling just a spot. You're not trying to sell the whole break. There are many reasons for that, but which I won't go into now, but it's to do with the efficiency of your trafficking in the ad decision server. But because we're carrying the same SCTI signaling as is going out to broadcast, our package stream has got markers for spots as well as the breaks. So that's created an interesting challenge for us in packaging. So let's take a closer look at that. So here you can see a manifest, a simplified manifest that I took out of ITV2 origin. I've stripped out all the adaptation sets because that's not what I want to talk about, but here you can see that we've got an event here for a break marker. It begins and ends, and it's about 4 minutes. That represents the whole break. But you've also got a spot marker in the same manifest that's pointing at a particular advert within that break. Now, that's useful for us because when we're not doing ad replacement, we can carry measurement of spots for adverts that we won't replace. Typically, that's not really something you do. Before this, we haven't actually launched that yet, but in the future we're going to do this. But typically, in-baked broadcast adverts were traded up with the broadcast on OTT, so there wasn't extra revenue particularly. So being able to measure broadcast adverts that weren't replaced gives us at least forecasting benefit, but potentially there's trading models around that as well. You'll note it's a single period. So right now our contribution format to the ad replacement is not multi-period. That's not normal. I don't know if the Google guys are still here, but the Google ad replacement product right now is expecting the broadcast adverts to be represented as multiple periods. We took the decision not to do that, and that's not a final decision, but right now this is what we're doing, single period. It's given us certain benefits right now. One of them is separation of concerns, so the package doesn't really need to know anything about ad logic at all. It just sees splice inserts, it sees events, it does its job, spits out what it needs, and the downstream systems can do what they want with it. So there's no real commercial ad logic in our packager. It's pretty simple. Additionally, it allows us where multiple periods aren't supported on clients, we can just send this out, and at least we've been counting adverts as well, direct to origin with no ad placement. So actually, there's some benefits. I think if I were a betting man, perhaps this won't stay the same and we'll be representing as periods, but this gave us it's more to speed to market advantage and simplifying the packager for the time being. And the other point I wanted to call out was the use of message data. According to the ANSI SCSI spec, you shall not use message data for carrying SCSI information. That wasn't deliberate, it's a work in progress, and it was an oversight, so we'll probably change that. But given it's a contribution format, it may or may not yet see clients. I'm not sure when we're going to change it, but for any spec experts out there, that was an accident, not deliberate. So moving on now to ad replacement side of things. We have a model of serving just-in-time ad replacement. So the decision for every single viewer as they arrive at the break is made as they arrive at the break. So that leads to a particular architecture. So I'm going to a little bit more deep dive into that. So the entire ad inventory for our system is backhauled into the ad replacement system as mezzanine files, and ahead of time it's packaged and segmented and transcoded. To Thomas's point earlier, because we're in control of the advert mezzanine and the content coming in, we can guarantee that it's the same codec, guarantee that it's the same bit rates, so we don't have that problem with transitions across multiple periods because we know exactly what we're going to get. So that's how that's probably not the same for everyone, but we don't have that problem of guaranteeing that the content either side or within a period is different. So the manifest is ingested from the origin into via a private connection and is being looked at. Do we have any ads coming up? And when we get an ad coming up, it triggers some logic. At this point in time, as I said, the decisions are being made on the fly on each edge node in the ad replacement system. A vast request is made and a vast response is returned, and the decision is made on the fly for every single viewer. So that leads to some interesting load challenges, and this afternoon's second graph. What we see is at sufficient scale, statistically, the load is distributed quite neatly over one segment's duration, and it typically breaks down into 1/3. So you get 1/3 of all the requests in the ramp up, 1/3 of all the requests as a peak concurrency, and then 1/3 of the requests as a tail going down. So that gives us a quite neat way of forecasting load, because we know exactly what, if we're forecasting that there are going to be X 100,000 requests for an upcoming event, we know what the ramp up will be, and we'll know what the peak concurrency will be. So far, our maximum peak concurrency is 1.1 million. We may need to rethink this when we roll out across all of the platforms. Not roll out yet, just when the load goes up, and potentially for low latency dash. Although it was said earlier that the dash IF setup was, I think you said, Thomas, it's 6 second segments with a 2-second gap, which is exactly what we've got. So if we stuck with that low latency dash and just do the chunked encoding, actually we wouldn't really need to change this. And architecturally, we may be okay, at least in the ad server. We don't need to scale up anymore. So that was helpful. So thank you. And finally, it's also mentioned, so as you said, those same spot IDs are sent to the client where the measurement happens. And as you said, right back in the scheduling system when it minted the IDs, the same IDs are then sent back to the ad decisioning server, and you've come full circle. So let's have a look now at the actual output of the ad replacement. We are now into multiple period dash. So you've got the content before and after. And you've got the ad break there. This is where I am overlapping, but what was said earlier. The use of dash events as a contribution, inbound events, is important because there's absolutely no need to look at anything other than the manifest. So it just keeps it as manifest manipulation. When you get down to dealing things on the client, we're switching to e-message, represented there as an inbound event stream, because you can guarantee that the accuracy of the reporting in the client that you are in the advert, which is important to us, to our customers, to know that it was definitely an advert being seen, and the quartile events were all reported properly. And then I thought I'd make a call out of the segment timeline as well, because it's quite interesting. You should be doing this live anyway, but it provides quite a nice syntax for representing the varying segment cadence. It's quite cool. So, on to the media player. So we are not quite, this is where we haven't finished yet. We are live for the channels on our website that are not ad replaced yet. We are already live with Dash.js. We like Dash.js, it's good. We also like Shaka Play. We did look at that, we recommend it, but we wanted to stay aligned with the industry. As a broadcaster, we prefer to stay aligned with the industry groups and how they're working. So really that was the only reason why we chose Dash.js over Shaka Player. I think Shaka Player is good. When we started out on this, we took the decision to pause on Safari while the dust settled on CBCS and CMAF. We're not quite ready to introduce that into our workflow, but we're not going to hold our breath for CTR mode either, after hearing Josh this morning. But we're about to start. I got an email today saying that we're now ready, so we're going to start working on, in Dash.js, testing our streams of multi-period Dash. So
So just letting you know your timer's out.
Okay, cool. This is my last slide, so it's great. Good timing. So one final bit. We're currently working in the horizontal market in the UK and HBB TV. We have a product called Freeview Play, which is basically an aggregation of broadcasters in TVs. So we're looking at multi-period Dash right now on market connected TVs. You go anywhere from really good transitions to a period will blow up the TV. So there's a bit more work to do, but from 2019 onwards, support for multi-period Dash and TV is mandatory, and we're driving that. We're also in the Freeview Play spec, which profiles HBB TV. We're describing behaviors for making seamless transitions to ensure that we can condition those new receiver devices coming into the market to be really, really seamless and snappy. And in this specification, we are mandating that content partners use the period connected to describe to let the receiver know that they are specifically, even though the media timeline is not, there is a discontinuity, that to expect that the codecs won't change and so on, so that you do get the best chance of getting a seamless transition. And that's it. Thank you very much.
Okay, thank you, Matt. Okay, we're running behind time. We'll take one question over here, but I want to get the next set of speakers here. We are going to be running over time, but the last section is content protection, and this is a really important topic. So for Matt, is there anyone who has any questions up here? Okay, we'll take one question. And Raj, I'm going to actually take the other guy's question.
Just change the slides. So how do you handle the content beacons, the ad beacons?
Can you repeat the question?
How do you handle the ad beacons in the Dash?
Sorry, I didn't catch it.
How are you handling ad beacons?
How am I handling the ad requests?
Ad beacons.
How am I handling the ad beacons? So what we do is out of band. So the e-message is received from the client, and that upon receiving the e-message, there's some JavaScript, or in this case some JavaScript or whatever the client is, calls out to ad replacement software and downloads the response to the VAST server so we can then see the impressions, and then it will, based on where it knows it is relative to the stream, it will call out the ad impressions based on the VAST that was received by the ad replacement system.
Okay. Thank you, Matt.
Pleasure.